Welcome. In this video I'm going to show you how you can perform a Cochran test for means, slightly different or actually different than a Cochran Q test. It's one of many tests that could be used to determine if some means are significantly different from each other. I'm not going into this video if you should use this test. For example, Hartung and some others did research and found the test too liberal compared to some other tests, but the test is used as a basis for some other tests, so could still be of interest. To show you how this test can be done with R, or specifically RStudio, I'll first need some example data. So I'm going to load in a data file. I'll leave a link on my website to this R script and also the data file. The data has about 55 observations and 50 variables, so 55 rows. And there are 50 variables. It's from some survey from many years ago among some students. I don't need all that data, I only need the ones for this test. It's going to compare means across different categories. So the categories will be based on the location, and the means will be calculated based on the grade. This was the grade that the students actually gave to the course. So I'm going to store that under selected data, and if there's a missing value, I actually don't need the entire row because it can't be used. So I'm going to omit any missing values, and as you might notice, we now have 48 observations left. The Cochran test for means can actually be found in the doix package. So if you've never used that before, you can use install packages and then with quotation signs doix, and then load the library using library and then without quotation signs. And then there's a CF function that will actually perform the Cochran test. It's a bit misleading that it's mentioning F because it's actually not using an F distribution, it's using a chi-square distribution. The test statistic is 20.9116. The degrees of freedom turns out to be 2, which is simply the number of categories, which is 3 in my case, minus 1, so it becomes 2. And then the p-value, which in this case is so small it got rounded to 0. This indicates that it's below the usual threshold of 0.05, which indicates to reject then the null hypothesis, which would then indicate that at least 2 of the means are significantly different, or that location has some impact on the average of the grade. If you don't want to use a library, you can actually follow all the steps of the formula. I have the formula shown on my website. It's hard to do that here in RStudio without using Markdown. It requires the counts for each category, which can be done by using an aggregate function. The means, the variances, and then I combine all those results into one. So that's being done here. So we can now see that, for example, there were 19 students in Haarlem who gave an average grade of 51.94, and the highest variance was actually in Rotterdam, so students there tend to disagree with each other on the grade. Then a so-called weight is calculated by simply taking the category sample size divided by the category variance. These will then not sum up to 1, so what's often done is we sum them all up and then divide each of them by that sum, and that's then an adjusted H value. I can show you those results as well. We then multiply each category mean with that adjusted H value, so to get and sum all those results. So there's the sum. And that gives us a weighted mean of, in this case, 63.20 and 5958. The chi-square value is then the original unadjusted weights multiplied with the difference of the sample mean of the category minus the overall weighted mean, and then squared those. And that gives us our chi-square statistic, and that should be that 20.91162 we saw earlier. As I mentioned earlier, the degrees of freedom is the number of categories, so in this case k, 3, and then minus 1, so the degrees of freedom should be 2. We can now use the chi-square one to actually calculate the p-value. So we feed it the chi-square value, the degrees of freedom, and indicate that we want the upper tail by setting the lower tail to false. And now we should be able to see our p-value, which is 2.878059 times 1 divided by 10 to the power of 5. So that's actually 0.0000 something. So indeed far below the usual threshold of 0.05. If you're interested, I made all of these steps into one big function. And that should, if I run it, give me the exact same results. Alright, and that's how you can perform a Cochran test for means using R. I hope this was helpful, and thank you for watching.